Welcome to my channel Supernet in Chemistry. This is my first video. Here we discuss structure of atom and how to distribute various electrons in various shells. So structure of atom, the center, a nucleus, you can see a nucleus contains protons and neutrons, together we call it nucleons, and different shells surrounds the nucleus, we call K, L, M, N. Shells otherwise called orbits or energy levels. Now, why orbits are otherwise called energy levels? Each orbit is associated with a fixed amount of energy. Electrons revolve around the nucleus in these orbits, so we call orbits shells, otherwise energy levels. Now, symbolic representation of an element X with its atomic number Z and mass number A. So standard representation X Z A or X Z A. A is the mass number, X is element, Z is atomic number. Don't confuse, A is the mass number, Z is atomic number, X is element. There is no reason for the symbols A and Z. This is a standard representation. Now, atomic number Z means that is also equal to number of protons, P also equal to number of electrons. So if you know the atomic number, you can easily calculate the number of protons and number of electrons present in an atom. And mass number A, that is equal to number of protons plus number of neutrons. So mass depends on the number of protons and number of neutrons. So you can easily calculate number of neutrons if you know the atomic number and mass number. That is equal to mass number minus number of protons P or atomic number Z, because number of protons also equal to atomic number. So these are the two important formulas to find the number of neutrons. N is equal to capital A minus Z. A mass number, Z atomic number, and Z atomic number is equal to number of protons and number of electrons. Example, hydrogen's atomic number 1, mass number 1. Therefore Z is equal to P is equal to E. Therefore number of protons is equal to number of electrons is equal to 1. Number of neutrons you can easily calculate, A minus Z. Mass number minus atomic number, 1 minus 1 is equal to 0. You note that the element without a neutron, that element is hydrogen. Another important information, an atom is electrically neutral. That means charge of an atom is 0. You know that proton, so positive charge, electrons, negative charge, and neutron, 0 charge. Number of protons and number of electrons in atom are same, therefore total charge is 0. This is the reason why atom is electrically neutral. Simply, number of protons and number of electrons are same in an atom, so an atom is electrically neutral, 0 charge. Now come to electronic configuration. Arrangement of electrons in atom, that is what we call electronic configuration or electron configuration. Arrangement of electrons in various shells of an atom, that is called electronic configuration. Now here, to understand more about electron configuration, first we should know Bohr-Bury scheme. The maximum number of electrons in each shell or orbit is determined by formula 2n square, that is rule 1. 2n square formula. Number of electrons in each shell can be calculated using the formula 2n square, where n is equal to number of shell means shell number, first shell, second shell, third shell, etc. Here you can see shells k, l, m, n, therefore n is equal to k first shell, l second shell, third shell, fourth shell. Substitute these values in 2n square. You can easily calculate the number of electrons present in each shell. K shell n1 2n square, 2 into 1 square 2. L shell n is equal to 2n square, you get 8. M shell you get 18. N shell you get 32, etc. So number of electrons in various shells K, L, M, N 2, 8, 18, 32 respectively. Rule 2. The outermost shell cannot have more than 8 electrons. Outermost shell, otherwise called valence shell. The penultimate shell, last but one, cannot have more than 18 electrons. A new shell is formed as soon as the outermost shell attains 8 electrons. When you distribute electrons in various shells, the outermost shell is completed by 8 electrons, then the next electron goes to the next shell. The penultimate shell means a shell before the last shell can have only 18 electrons, cannot have more than 18 electrons. Examples: hydrogen atomic number 1, so only 1 electron in K shell. Helium atomic number 2, only 2 electrons in K shell. K shell can accommodate only 2 electrons. So for neon, 10 electrons, first shell 2, remaining 8 in L. Sodium 2, 8, 1, because L shell can accommodate only 8, next electron in M shell, 2, 8, 1. Argon 18, 2, 8, 8, that means 8 plus 2, 10, plus 8, 18. Potassium 19, 2, 8, not 9, but it is 2, 8, 8, 1. We have to apply the above rule. The last shell is completed by 8 electrons. The next electron goes to the next shell, that is N shell. Calcium 20, 2, 8, not 10, but it is 2, 8, 8, 2. So for calcium and potassium, valence shell is M. For potassium, only 1 electron in valence shell, that is the valence electron. For calcium, 2 electrons in its valence shell. Here you can ask, the third shell can accommodate 18 electrons, then why this happens? See here, electrons are situated in orbits, as you know that, but you will study this in detail in class 11. In atoms, electrons are not only situated orbits but also in orbitals. Orbitals are called subshells. So in atoms, not only orbits but also orbitals or subshells are also present. So when you distribute the various electrons based on subshell configuration, you can see third shell can accommodate 18 electrons. You will study this in higher classes.